Hi friends, in this session we are going to see how a mathematical concept is useful in real life. Let's see an example. Hey Jack, why are you looking so tired? Yes, I am tired of this task, John. What task? I want to hang this LED light exactly at the center of this building, in a way that it should also be parallel to the base of the building. Okay, that's it. Yes, and one more thing. I also want to know the required length of the light. Fine, don't worry. Consider it done. And let me assure you that this task is very easy. How? Let me explain. Since these walls of the building resemble a triangle, so first of all, we shall take the center of both the sides of this triangular wall except the base, and then join both the centers with a line. And Jack, this line is not exactly at the center of this building, but also we can consider it to be parallel to the base of the building. And about the length of the light string, it will be half of the base of the building. It means if base measures 50 meters, then the length of the lighting will be 25 meters. Oh great! But John, how do you know these things? Well, I know all of this because of my love for geometry. And there is one particular theorem which says that the line segment made from midpoint of two sides of a triangle is parallel as well as half of the base, that is the third side of the triangle. And it is called midpoint theorem. So let's learn it in detail. Let's make a geometrical figure from the building and name it. We have taken point R and S as midpoints, because of which AS is congruent to VS and AR is congruent to TR. Now in here, we have to prove that RS is parallel to TV and RS is half of the TV. So firstly, we'll have to do a small construction. Let's construct the line segment VP, which is parallel to RT, and extend RS to join point P. Now we can prove everything in 3 simple steps. The step number 1 is, we'll prove the two triangles are congruent. In the second step, we'll prove that the quadrilateral RTVP is a parallelogram. And finally, we'll prove that RS is equal to SP. So without wasting any time, let's move to step number 1. First of all, we'll take both the triangles for comparison. So AR is parallel to VP. For being alternate angle RAS is congruent to angle SVP. And the segment AS is congruent to segment SV because point S is the midpoint of AV, right? Then angle ASR is congruent to angle VSP because they are opposite angles. And according to angle side angle congruency test, triangle ARS is congruent to triangle VPS. Hence, AR is congruent to VP and RS is also congruent to SP because they are the corresponding sides of congruent triangles. We know that AR is congruent to RT, and we just proved that AR is also congruent to VP. Therefore, we can say that RT is also congruent to VP. Now the step number 2. In quadrilateral RTVP, RT is congruent to VP, which we just proved, and RT is also parallel to VP. So according to the property of a parallelogram, can we say that quadrilateral RTVP is a parallelogram? Yes. And friends, RP is parallel to TV because they are opposite sides of a parallelogram, right? Therefore, being part of segment RP, RS is also parallel to TV. So the first part is proved. Are you getting it? Great, John. Hats off to geometry. Mathematics indeed makes our life simple. Yes, but John, I have another question. Is this line really half of the base? Definitely. Can you prove that also for me? Yes, sure, why not? Our third step is about that only. Quadrilateral RTVP is a parallelogram. So RP is equal to TV because they are opposite sides of a parallelogram. Correct? Now, RP is nothing but RS plus SP. But already we have proved that RS is equal to SP. It means RS is half of the RP, right? And because RP is equal to TV, so we say that RS is also half of the TV. That was so simple, John. If you don't mind, I have just one last question for you. No problem, Jack. Feel free to ask. Can we apply this theorem on different types of triangles? Good question, Jack. Yes, we can use this on any type of triangle. Thanks, John. Now I will also keep midpoint theorem in mind while solving such situational problems. Do share this video with your friends.